Welcome to this tutorial of the Kratos ROM application. This is the fifth tutorial of the series, and here we are going to start talking about some advanced options in the ROM application using the ROM manager. We will cover, first we will use the structural mechanical example, so we will need the same requirements as we did for setting up the structural mechanics example, that is GID or ParaView. This is only for post-processing, and the structural mechanics, constitutive laws, and ROM app. Here are the topics that we will be covering in this ROM advanced options. First, we will start with the database. Then we will talk about how to input parameters using the analysis stage. This is the third way of inputting parameters, as we had mentioned before. And then we will continue with other topics. Let us start by saying that the ROM database, this is the class that is part of the ROM application, and it is an SQLite 3 database. So when you call these methods fit and test, and the data is stored with a hash name. So what does this imply? It implies that once the files are created, that is snapshot matrices or any data inside the simulation that is used by the ROM manager, then simulations are not repeated if existing. So the database, one of the usages of this database is that before launching a simulation, it goes and checks, the ROM manager goes and checks whether this simulation has already been executed for the parameters that we are intending when we input in the ROM manager, what type of projection, what tolerances, etc. We will continue in the following tutorials to see all of the parameters possible. But if for the existing parameters this simulation exists, or these results exist, these matrices, and we will see that they are actually NumPy arrays, then no double work is done. So it will go to the database and it will fetch the required data. And I mean, this is done automatically inside the ROM manager, but a user can take advantage of that and already fetch snapshot matrices or require data from the database using a simple function call to the ROM manager database. So that's what we are going to be seeing. And yes, let's go to these are the files that we have created in this tutorial so far. So let us go to the structural mechanics example. You will see that we had these files, we have still the MDPA, the Python, and the two JSONs. This post.lst, this was created when launching the GID output. This is a secondary file, we can eliminate it safely. And here you will have two folders. The first folder contains the results in VTK and GID, but we have this ROM data folder, which if we inspect it, we will see that we have two NumPy arrays, node IDs and write basis matrix. These are necessary for the simulations, and particularly this JSON file contains, we open it, it contains similar data to what is inputted for the ROM manager. You will notice that we have not all unknowns. This is something that we have to input in the ROM manager, but it also have some, this projection and assembly strategy. We will see in later videos what this means. So the ROM manager takes care of writing or overwriting this and fetching it whenever necessary. So if we were interested in launching simulations, ROM simulations standalone, that is without the ROM manager, we would need to make sure that the correct parameters are set up here. Since we are using the ROM manager, this is a file. Actually, all of these files can be extracted from the database, as we will see. What is inside the database? This is the .db format. This is, if we try to open it, tell us that it is an SQLite 3 database file. So this is the database. It is we can imagine this to be kind of a table, and actually if we open these Excel files, we will see a summary of what is inside the database. If we open it, we will see that this is indeed, you have all of the tables that the database contains. By the way, this is only for reference, so there is no direct link here. This Excel file was created, it is a summary of it, so it will only create at most five rows of information. And there's also a method in the ROM manager to dump the complete database as an Excel, but changes here will not affect the database. This is only created in one direction. So we have full order model, reduced order model, and hyper reduced order model. This is the HROM that we will see later in the tutorial. But these are simulation results. The first three tables are simulation results. Then we have non-converged solutions. We have not data. We have not fetched. Basically, we have not saved the non-converged solutions. Then we have write bases, and this is the one that if we go back here, that's the one that is here, write basis matrix. But it's telling us that it was created with solution tolerance of 1 to the minus 5, and it didn't use non-converged solutions for the creation. So singular values of the solution, left basis. So these are all intermediate data that is available in the ROM manager for the ROM manager. If it's computed, it will store which parameters were used for computing it, and for example, if any of the existing, if I try to launch a simulation again, let's go back to the simulations. If I try to launch a simulation again with these particular values of the loads, then it will not launch it. In this case, you can see that it says generic name 0, generic name 1, and generic name 2. These are the loads. You will see that it has 20, 45, and 60. These are loads for this particular structural mechanics example that we inputted directly to the simulation. But this generic name 0, this is because we didn't input here. I am here in the ROM manager implementation. You will see that one of the parameters of the ROM manager can be these mu names. This is a list that should have a list of strings that should have the same dimension of the input parameters, so that this is only for reference, so that here we can have the correct name. If we don't input anything, it will have this generic name key. If we go to the implementation of the ROM database, this is, as you will see, this is the class that is managing the database inside the ROM manager. But it's a different class, but the ROM manager contains it, has an instance of this class. So you will see there's an explanation here for mu names. This is a list of parameter names, a single list with the names of each parameters to be used for reference in a database. For example, alpha, permeability, mag. So the only condition is that it has the same dimension as the input parameters, and as it says, only for reference. So that's the generic name. So we have a combination of loads, and this is the hash name. The hash name, this is hash 256, if I'm not mistaken. Let's see, hash SHA 256 hash. So this is an encryptation of one way, so that basically what it does, let's go to, it takes the parameters for that simulation. For example, if we are storing the results for a full order model simulation, it only tells me what parameters were used for generating it, that is mu, and then the table name, which is FOM. If it is checking, for example, a reduced order model, it will tell me not only parameters but also some truncation tolerance, projection type, decoder type, whether I'm using converged solutions or not, and you will see there's a lot of parameters, so that it generates a unique hash. This is the hash that we have here, and then that's the way it has to compare whether this file already exists in the database. Where are these files? These ROM files, for example, HROM, as we said, we have none. Where are these files? These files are in the npy files folder. So in ROM database, npy files, here we have all of the files that I'm referred to in the database. So what we can see is this ROM database.db. This is a table, and here we have the summary. We can generate a complete dump, but what it does is it is an object that is queried whether something exists or not, and if it does, it goes to this folder and fetches the matrices that it requires, and if it does not exist, it generates it, stores it in this folder, and adds it to the table, to the corresponding table, so that in the future we don't have to launch it again. That's the idea of the ROM database. So let us just see. This is the simulation that we launched in the previous tutorial, that indeed, if I do this, let me not use the run methods, because the run methods will continue launching the simulations. It is with the fit and test methods that it does not launch the simulations again. Let me just see if I can show that we will not see the output of the simulations being generated. So we only have outputs of exported quantity of interest, so it just exports this Excel file. You will see that data exported to Excel file successfully. So it just goes and checks whether it has whether it has the data in the database. Just for us to sim with, let us eliminate this, and let's see how the output of this terminal change. Let me just put that. We will see that indeed here so we have that the simulation actually launched, and then an NumPy was saved to the database. Here we have another one of those, another one. So we have all of the simulations being launched. Here you will see that the simulation finished. In particular here, for example, we can see that numerical linear algebra computation, that is the singular value decomposition that we will see in the following tutorial, was carried out, and 2 NumPy arrays were stored. So that was for this particular launching of the parameters. I can clear it, and I can launch again, and I will see that the simulations will not launch again. I will only see the output of the database being exported to the summary Excel file that I had seen before, and then these approximations, since I requested them. So it didn't launch the simulations because these are already contained. Clearly, if I increased, this is already contained. No, this is not contained. So I added a new one, and at least it will launch one full order model simulation. You will see it launched at least one full order model simulation, and it did a singular value decomposition again. If I launch, since this is already in the database, it will only prompt me the update of the summary Excel file. That's it. That's the database. So we have checked this first point that says that simulations are not repeated if they exist. And let me just show you how to retrieve information in NumPy. So here, so I don't need to do the fitting. I can do ROM manager dot database dot get snapshot matrix from database, and then I should put here, for example, mu train. So that I input a list of lists of the cases that I want to see, and then I just put the table name, in this case, for example, the full order model. Let me store this in an object A. Well, let me call it snapshots form. And then I will print snapshots form. This is a NumPy array, so I'll put shape. And it indeed tells me that this is a 680 by 4. That's the number of degrees of freedom that I have. So I have 340 nodes, and I have 2 degrees of freedom per node. So I have displacement in the x direction, displacement in the y direction, and indeed I have 4 of these mu train parameters. So I have four columns in this matrix. So that's for one example of how we can fetch simulations. Of course, I can also fetch the ROM simulation. So snapshots ROM. So we'll it will have the same dimensions for sure, but I can also print their difference. For example, mp.linkalg.norm lin so in this way. Okay, I don't have NumPy imported, so let me just go ahead and import it in the top, of course. Import NumPy as np. There you have. So put away these print errors. Check. That this is equivalent. So not computed because I didn't put the fit. So in order to call print errors, I should put fit. Now this should be here. And actually, inside the ROM manager, this print error function, it's going to do inside the ROM manager for us exactly what I'm doing here. It's going to go ahead and call the database of the full order model. The database it will also request the reduced order model, and it will do this operation, the link alg. This is the Frobenius norm of the two matrices, but it will divide it by the Frobenius norm of the full order model. So in this case, I should get the same output in print errors and in the operation that I'm performing here. So let us see. One point, as you can see, this is the one that was outputted by the ROM manager. When I set print errors, it would set approximation error in train set form versus ROM is 1.047 e to the minus 11. And when I went ahead on my own and fetched from the database, I fetched the solution matrices of the form and of the ROM, and I computed on my own the norm. It is the same. So that's one way in which we can fetch data from the database We can, of course, we don't need to fetch the complete set of mu train. We can just, this is a list of lists that we should put here, so I can put a single instance of this, right? So let me keep it here for in case someone wants to launch this one. And here I will just single snapshot, and I will just print here so in this case this should be a column of 680 by 1, and that's what I get. So I can use this function, get snapshot matrix from the database. I just need to specify which of the tables I want and for which parameters I want it. It can be for the complete data set, for the complete set of parameters, and in this case for 1, let me just put here 900. So this is not existing in the database, right? So this should generate an error. Basically, retrieved snapshot metrics for form does not contain one case. So this case doesn't exist in the database because we have not created it. So before before launching a computation inside the ROM manager, what it does is it goes ahead and checks whether it contains it. If it does not contain it, it computes it, it creates it, and it stores it in the database. So a similar check is performed, and if it doesn't have it, it launches it. If it does have it, it fetches it. That's the idea in the database. So that's what we have done, and it only does it for the feed and test methods, because it of course creates an overhead to store the information. When you use the run method, it will always launch the simulation, because it is understood that when you use the run method of the ROM manager, you are actually interested in launching a simulation. Even again, 2 times, you're interested in launching that particular simulation at that instance, so it doesn't produce any overhead by checking and storing information. Only if you do want to, you can do it on your own. So in the following tutorial, we will see exactly that, how to perform this analysis stage modification. This is the 3rd way of imposing parameters that we mentioned, and that's for the next tutorial.